Okay, thank you for this opportunity. So I'm going to be showing you the results of an early scoping project, which our research council funded, and the kind of where we are at with a pilot in terms of testing the results. And this work comes from initial scoping work by a research council, National Environment Research Council, when the concept of digital twins landed, and they created a raft projects for pilot studies, and then they also created kind of this kind of project in the middle, which is an information management framework, which actually is about how you can enable interoperability and interchangeability in digital twins. And it's a work of many, as you can see by the author list. I'm really presenting the work of a hand-picked brilliant team of actual data engineers and technical specialists that brought produced these results. So the first thing that we generally show in our project is, this is the question that always hurts us and always slows us down. So we always have one slide at the beginning about what's digital twin, gives you the context of what we're doing and why we're doing it, and the scope of the work we're doing. In terms of this work, the definition of digital twin we're using, it's a digital twin. It's a virtual representation of a physical asset enabled through data and simulators for real-time prediction, optimization, monitoring, controlling, and improved decision making. The key thing we need from this is improved decision making is the key output our research council is looking for. And then this information management framework that we're talking about, which is where we start to bring these things together, it's kind of shown in this figure on the right. But effectively, it's about working across different digital twins, different activities. We don't see there being one digital twin for everything. We see there being many twins with potentially interchangeable components. And it's about getting a shared vision with all within the community, developing a conceptual framework so you can enable interoperability. And then setting up a digital commons, and digital commons is that means to kind of share those assets and the standards and develop those standards together. There are demonstrators, and the key things is we can't just do a conceptual piece of work that's of no use to anybody. We need to actually deliver a demonstrator to show its actual use, its actual practicalities, and that also further shapes those requirements, because each demonstrator gives you new requirements which you then need to put in the future, and developing those components. And effectively, the project I'm going to show you, the two projects I'm going to show you, first one very briefly, actually kind of scope this type of work. The second one is about a pilot study, which actually I'm going to show you a pilot study of Hay Cress, which is a marine protected area off the southwest of the UK. So the first project, just got one slide on this, and we did this, the results we produced May last year, and the project lasted about 6 months, where we actually scoped this information management framework for digital twins. We started with the Centre for Digital Built Britain, because they'd already done a report on scoping this type of activity. We brought in environmental digital twin landscape, and that helped us produce a draft information management framework. And then we also brought in the use cases. So these components here, these are also from the Centre for Digital Built Britain. So you've got the foundation data model, reference data library, integration architecture, governance, and potentially other components. And they're all elements of that Centre for Digital Built Britain scoping. We combined it with actual use cases. So we went out to the research community, and we found about 20 different potential use cases to look at. And we actually landed on 3 to try and give us as much scope as possible for this work. The first is British Antarctic Survey, and they're developing a digital twin of the Antarctic, and also digital twin of the David Attenborough new research vessel, and a digital twin of the sea ice. And the goal is to optimize the pathing for the David Attenborough to minimize fuel burn as part of net zero. Land Insight, which is by Centre for Ecology and Hydrology, which looks at soil moisture and carbon. So it's key for things like the International Panel for Climate Change Monitoring, and also farmland and sustainable use of the land. And then 3DT, which is by the Met Office, and it's atmospheric dispersion. So if there's a pollutant released in the atmosphere, they want to actually model that, get the really local effects, and use that to actually inform the decision-making and monitoring there. And the results of this project are already live on the DT Hub web pages. So if you actually want to read the full report, that's actually downloadable there. Second project I'm going to show, which is the active project, I want to spend a bit more time on this, and the other one is a pilot. So actually running from October through last year through to November this year. We're about halfway through, and we're actually going to pilot this work. So we've kind of scoped what this framework will look like, And we actually want to run a pilot and actually evaluate this to see if it works. And this is actually built from different areas. So first bit is we've got a pilot study, which is a HAGFRAS, using digital imagery of the seabed in order to do the monitoring of biodiversity. We're going to build a generalizable framework. So effectively, we interchange of the twins, and we're actually working with Richard Targeted Survey around actually sharing components, code describing components, making sure we've got interchangeability. And we've got a development framework. So this is a theoretical landscape and actually formalizing the theoretical results for the first project. We've got a significant stakeholder community. So we actually got a senior stakeholder community, and we've got effectively a community of practice type effort in terms of engaging stakeholders. And our outputs are going to be an updated framework, and that paper is actually starting to come to life now. IMFe services. I'm going to show you the first one of those, which is the asset register, and also this digital twin of which is effective. I mean, my boss says we need a twin to kick the tires off. Building a twin of the HAGFRAS as a demonstrator. So this is the digital twin that we're trying to build in the first instance, and it's for marine biodiversity. And you can see here, got a bunch of images of the seabed. And if you look really closely in one of these, you can see part of a lobster. It's quite tricky to see, and that's why this work is so hard. They actually want to use AI machine learning to actually identify those species to inform future surveys, and effectively as part of the regulatory monitoring of that region, because it's a marine protected area, you can actually, because we use a big, effectively autonomous vehicles to go do the survey, we can actually form a path in those vehicles to do better surveys as we go on. Leave that one there. And the second one, a key element we're going to get, which I think is particularly relevant to this community, is an asset register. So one of the key components we see from the work is effectively a shareable description of a twin, which covers those components, makes them discoverable, means you can understand what we've done in a twin. And what we're going to do for that is we're building an asset register. And that covers all of these different types of components. So we've got analytical utilities, sensor network outputs, baseline data sets, other data sets, visualizations, and effective standards and best practices we've used. And this means that effectively any twin that's described as such an asset register, we don't see this asset register as the solution, but it's a first cut at a solution which others can take and evolve, is to document a twin, make sure all those components are discoverable, and then potentially in the long term actually get machine actionable kind of sharing the components. And I'm going to show you briefly where that's at. This is the asset register at the moment. It's empty, but we've got that baseline framework up. And over the next coming months, if you're interested and if you keep track of it, you'll see we're actually going to start to populate this with components. So that's actually coming together as well. Going to go do a little bit on outreach before we close. So there's two key areas of outreach that we're actually following. The first is what's called Digital Twins of the Ocean. So as part of the UN Decade of Sustainable Ocean, which is a key international activity, they've actually created a program called Digital Twins of the Ocean, or DITO is their acronym for it. And it's about making it accessible with open and equitable access to data, information, technology information. They see digital twins as a key solution to actually open up the ocean to a broader community, and that's not just researchers, so it actually goes down to policy and governments and industry. And then the goal is comprehensive digital representation of the ocean. And I think the key thing that's come out of this is not going to be a single digital twin of the ocean, it's going to be many twins, which means we need this framework. And the sub-action for that's called Turtle, which isn't an acronym. The chair just likes turtles. So we've got this action called Turtle, which is about actually having this broad framework in the ocean community to enable those components, the data, the elements, digital twins to be shared. And this project is actually registered as part of that action. Second key action that we're engaging with is the Turing Research and Innovation Cluster. They did their launch event about a month ago in London, and they wanted to produce open, reproducible computational tools to provide these tools at international resource. And they've got three themes: there's environment, infrastructure, and health. And the work we're doing potentially spans those. If you look at something like wind farms in the North Sea, that's actually got infrastructure and environment elements to it. If you look at the 3D T-twin for the Met Office, that's potentially got elements of the health in there. And that's kind of what I've got. And then we're going to go to questions, but one of the key things that I've got a meeting with John tomorrow, we're going to potentially look at increasing our involvement with DT Hub as well. So thank you.